Welcome to this explainer. I'm really thrilled to have you here today. Whether you're a cloud architect, a site reliability engineer, or an IT ops pro, we are setting the stage for a deep dive into mastering visibility within the Oracle Kubernetes Engine, or OKE. Look, if you're managing cloud-native applications, you already know OKE is a powerhouse. It's a fully managed container orchestration service giving us enterprise-grade features, high availability, scalability, security, right out of the box. But well, with all that immense power comes a highly complex dynamic environment. So let's dive right in and see how we can truly master our operational insights.
First, I want you to ask yourself honestly, are you kind of flying blind in your Kubernetes environment? Because running a complex deployment without comprehensive visibility is frankly incredibly risky. Think about it. By the time a user actually reports an application error or a node drops offline, you are already way behind. Without actively collecting and analyzing logs and metrics from your containers, your nodes, and your networks, you're essentially just waiting for critical issues to happen rather than preventing them. Effective logging and monitoring, they aren't just nice-to-haves anymore. They are absolutely essential for optimizing resources, troubleshooting, and hitting those strict compliance requirements.
All right, to get us out of the dark, here's our roadmap for today. Number 1, the OKE Visibility Challenge. Number 2, the Dual Agent Architecture. Number 3, OCI Logging Analytics Power. And finally, number 4, managing your cloud costs.
Okay, kicking things off with Section 1, the OKE Visibility Challenge, and why seeing across your entire stack is absolutely crucial.
You know as well as I do, to get true operational insights, you can't just stare at your app and ignore everything else. When we talk about the stack, we're really looking at 3 specific tiers. First up, the infrastructure tier. That's your underlying compute instances and the network holding the whole shebang up. Second is the Kubernetes platform tier itself, basically how the cluster is orchestrating your containers. And third is the application tier, the actual cloud-native workloads you're running. If you're missing data from even one of these tiers, well, you've got performance blind spots that can literally take down your entire system.
Moving right along to Section 2, the Dual Agent Logging Architecture, where we'll look at the specific collectors doing the heavy lifting.
Now this is where it gets really elegant. Oracle handles data collection using 2 distinct specialized components. Over on the left, we've got the FluentD-based agent. FluentD is this fantastic open-source data collector that creates a unified logging layer. It runs as a daemon set and replica set right on your Kubernetes cluster. What that means is there's an instance on every single node dedicated entirely to hunting down and grabbing logs. Then, on the right, we have the management agent. This one acts as a Prometheus scraper, running as a stateful set, and it's totally dedicated to metrics. So logs on the left, metrics on the right. Both working perfectly together to pump data straight into OCI logging analytics.
So, what exactly is that FluentD agent pulling in? The real beauty of this pipeline is the sheer variety of log types it unifies. It's grabbing your generic Kubernetes container logs, your underlying Linux sys logs, kubelet logs, and Kubernetes objects logs. But it doesn't stop there. It's also pulling Linux audit logs, your custom app logs, and even VNC flow logs. All of this disparate data gets scooped up and sent directly to OCI for processing. It's incredibly thorough.
Meanwhile, that management agent is working hard on your metrics. It uses some very specific service plugins to interact with your data sources and fire that data back to the OCI Management Agent cloud service. And these plugins are super powerful. They enable stack monitoring, they integrate with logging analytics, and they even tap into database management and operations insights. There's also a plugin specifically for Java usage tracking. So you aren't just getting generic high-level container metrics here. You are getting deep, granular, end-to-end monitoring of the actual services running inside your environment.
Let's dive into Section 3, OCI Logging Analytics Power. This is the central nervous system where all that data actually becomes useful to us.
Listen, every SRE watching this knows the absolute agonizing pain of manually troubleshooting an issue. It's 3 a.m., you're staring at terminal screens, frantically grepping through text files, just begging to figure out why a pod crashed. OCI Logging Analytics shifts you entirely away from that reactive, manual nightmare. Since all your data is ingested into this one cloud solution, you can index, enrich, aggregate, and correlate everything in a single place. It literally lets you find that proverbial needle in the haystack among millions of log records. And it does it fast. How does it actually do that? Well, it puts some massive analytical capabilities right at your fingertips. We're talking topology-aware exploration. We're talking over 250 out-of-the-box parsers for virtually any log type you can throw at it. You can visualize and analyze log patterns directly, plus you get easy data archival for cheap long-term retention. All of this lets you support engineers build these amazing custom dashboards. You get a single unified view of your cluster summary, and then you can click right down into individual pod statuses and workload performance in an instant.
But here's where it goes from being just a great tool to an absolute game changer. Logging analytics comes with predefined machine learning capabilities. These ML algorithms actively identify anomalies and issue patterns straight out of the log data. You don't have to guess what normal looks like anymore. The ML models learn your specific environment and proactively flag the weird stuff for you. This saves literally countless hours of manual troubleshooting. All right, finally, let's look at Section 4, Managing Your Cloud Costs. Because let's be real, your observability strategy has to make sense for your budget.
Let's break down the cost impact. Obviously, costs depend on the volume of logs and data points you generate, but Oracle offers some incredibly generous free tiers. For the logging service, your first 10 gigabytes per month, completely free. Logging analytics is charged by storage units, which are 300 gigabytes each, but again, the first 10 gigabytes are free. For monitoring, all internal service metrics are totally free, and for custom metrics, your first 500 million data points are free. Even the notification service throws in 1 million delivery operations and 1,000 emails per month at no cost. It is a crazy cost-effective way to get enterprise-grade visibility.
Which brings us to a massive pro tip, the number 90. When you're modeling your storage costs, we highly recommend maintaining exactly 90 days of active storage. Why 90? Because it's the absolute sweet spot. It gives you plenty of runway to troubleshoot day-to-day issues, but more importantly, it gives those machine learning models enough historical data to accurately detect anomalies. Once your data hits day 91, you simply move it to cheap archival storage where you can still recall it quickly if an auditor ever comes knocking.
So I'm going to leave you with this final thought. Is your OKE environment truly optimized, or is it just running? Setting up customized logging and monitoring with FluentD, the management agent, and OCI logging analytics does so much more than just keep the lights on. It empowers you to proactively detect issues, secure your operations, and actually sleep at night. Don't settle for just running. Take these strategies and optimize your deployments today. Thanks so much for joining me on this explainer, and keep building great things.